up, what up? I'm the math teacher Goat, and today in AP Precalculus land, we are doing a full lesson on 1.8 rational function and zeros. You can't spell rational functions without fun. And that's what we're going to have today. Go to the description, download the notes, and follow along, please. The notes are there. Like and subscribe. Leave a comment. Tell me how much you love me, please. Definitely subscribe, though. All right. Here we are. Rational functions continued. We did stuff like this yesterday, or the previous lesson, whenever that was that you watched it, because I know you did. Simplify x squared minus 9, all divided by x squared minus 4x plus 3. So factoring is going to happen, and more factoring is going to happen, and I'm expecting things to cross out. Now, we have a difference of squares. Two numbers that add up to nothing, but multiply out to negative 9 are going to be x minus 3 and x plus 3 in no particular order. Two numbers that add up to negative 4, multiply out to negative 3 are going to be x minus 3 and x minus 1. Let's get a different marker, cross that out, and that leaves us with x plus 3 over x minus 1. Now, what did we notice after we plan on sketching this graph above? Okay, well, I already know what's going to happen. I already know that if I have a negative 3 on the bottom and a negative 1 on the bottom, I'm expecting explosions to happen at 3 and explosions to happen at 1. So let's do Desmos for this one. Let's run to Desmos, graph that guy, and see what happens when we do that. Okay, let's do a little bit of graphing. We had ourselves, I'll do y equals x. Hold on, let's do a big division symbol before we do that. X squared minus 9, and then x, it's taking place, x squared minus 4x plus 3. Now I'm expecting wait a minute. Didn't I say before that there should be 2 explosions? I mean, I see the one at 1. I see that here at 1, there's my explosion taking place. But why don't I have an explosion at 3? I thought I couldn't plug in 3. Well, let me zoom up. Let's zoom up and see what happens when I trail along 3. Close, 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 close. Whoa. Wait a minute. What the flip? What the flip? What the frig? Oh, I lost it. Huh. Well, it says it's undefined, but why doesn't it explode? I'm going to go back and I'm going to try to make sense of this all. All right, so the picture that I drew, okay, basically we saw that happen, we saw that happen. Okay, so, explosion happening at 1. But over here at 3, okay, over here at 3, I didn't see an explosion, but I saw a little spot where it said it was 3 and then undefined. That's very interesting. Oh, you know what? These guys cancel out. Oh, so it would make sense, I guess, that even though they cancel out, you still can't plug 3 into the original problem. However, since they cancel out, it's not going to behave this way. It's going to behave that way. So the explosion is still going to happen at 1, but you still can't plug in 3. I wonder if they have names for those explosions and undefined things. Well, they do, and let's talk about them. First things first, we know our zeros. Okay, now if you're looking at a rational function, and if you're asked to find these things right here, what you're going to need to do is factor the numerator and the denominator like I did up there. Okay, now, if what you have is factors in the numerator only, okay, factors in the numerator only, you are going to get your zeros. So zeros exist in the numerator only. So I would look at this and notice that if you were thinking zero product property, I have magic numbers at -3, +3, and +5. Okay, down here in the denominator, thinking of magic numbers only, I have -2, 2, and 4. My zeros are where you have unique factors in the numerator only, and that happens at -3, +3, and positive 5. Now, vertical asymptotes are when you have unique factors that exist in the denominator only. So I don't know exactly what this graph looks like, but I could look at this graph and say something happened up here, but it appears to me that I have a factor at, what is that, 1, 2, 3, wait, 1, 2, 3. So if that's negative 3, that means I have a factor that is x plus 3 because our magic number would be negative 3. And that's 1, 2, 3, so I have a factor at x minus 3, which means our magic number would be regular 3. And so vertical asymptotes, which you've seen before, are what makes a unique factor in the denominator only. Okay? And what happens is you see an explosion take place. You're not allowed to plug in negative 3, and you're not allowed to plug in positive 3, otherwise this will happen. Now that brings us to this guy, the hole. And if you're like, whoa, 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 why didn't that happen? Well, a hole exists if you have a factor and the same exact factor in the numerator and the denominator. So in the problem up here, or in this problem, it looks like, what is that, 2, 4, so we'll call that 5. What's going to happen here is, I don't know what the whole thing's going to be over here, and I don't know what the rest of this thing is going to be over here, but I know I have x minus 5 and x minus 5 because my magic number is 5, my magic number is 5, and that's where it takes place. What will happen is these guys will cancel out, and the behavior of the graph is going to take on the behavior of what happens after it cancels out, but you're still not allowed to plug in 5 into the original problem. Okay? So when you see these problems, what you need to do is factor, list your magic numbers, and see what happens here. Find the zeros of the function. Identify the vertical asymptotes and determine if the function has any holes. This guy is factored out already. Using the zero product property, I'm going to find our magic numbers. Negative 1, positive 5, and negative 3. Now, magic numbers in the numerator only are zeros. So negative 1 is a 0. 5 and a 5 is going to be a whole because magic numbers that occur in the numerator and denominator are wholes. At negative 3, since it's a unique factor in the denominator, we have a vertical asymptote. So let's write down we have our zeros are going to be at x equals negative 1 because it has a unique factor in the numerator only. I have 5 and 5 here, so that's going to be a whole. My whole exists when x equals positive 5. And my vertical asymptote is when I have a unique factor in the denominator only. That happens at x equals 3. And yes, that is the straight up and down line x equals negative 3. Now, if you have a very picky math teacher and they're like, I want the exact value of the whole, then this is what you would do. Okay? The graph takes on the behavior of everything after you get rid of the factors. So if you need the specific value of the whole, what you do is you simplify the equation, leaving you with x plus 1, that's supposed to be a 1, over x plus 3. We now plug in the fact that the whole exists at 5, so that becomes 5 plus 1 over 5 plus 3, which becomes 6 over 8, which simplifies to 3/4. So the exact location of the whole is going to be 5 3/4. Now, most teachers are okay with just what's here in red, the Jesus script. But if some people want you to be specific, you have to simplify before you plug in the number. Because if you try to plug in the number before simplifying, you're going to get undefined, and that's no good. Okay? In fact, you're going to get 0 over 0, which is not undefined. That's indeterminate. Fun stuff. Speaking of fun stuff, let's keep going. The same exact rules apply. Find the zeros of the function, identify the vertical asymptotes, and determine if the function has any holes. So using the zero product property, let's factor this out. It's already factored. My magic number is at 0, positive 6, negative 2, positive 6. Okay? 0 is a unique factor in the numerator, so you're a 0. 0 is a 0. 6 over 6 gives me a whole because it's repeating in the top and the bottom. And negative 2 is a vertical asymptote. So my zeros, well, 0 is x equals 0. My vertical asymptote is x equals, what was it, negative 2. And my whole exists at 6. Okay? And again, if you need to find the specific value of the whole, you cross that out, you cross that out, you get 6 over 6 plus 2, which is 8. 6 over 6 plus 2, which is 8, is 3/4 again. Very, very repetitive. Now here we are. This is not factored out. So we have to factor it out. Two numbers that add up to 1, positive invisible 1, but multiply out to negative 6, are going to be x plus 3, x minus 2. Two numbers that are a difference of squares that multiply out to negative 1 are going to be x plus 1, x minus 1 in no particular order. Using the zero product property, my magic numbers are going to be negative 3, positive 2, negative 1, and 1. Negative 3 doesn't repeat in the denominator, so you're a 0. 2 doesn't repeat in the denominator, so you're a 0. Negative 1 doesn't repeat in the numerator, so you're a vertical asymptote. And 1 doesn't repeat in the numerator, so you're a vertical asymptote. So my zeros, there's 2 of them. My zeros are x equals negative 3 and 2. My vertical asymptotes are the vertical lines, x equals negative 1 and x equals 1. I'm writing them both out because they're equations and it just looks better that way. I think so. And then my holes, well, there are none. No holes. Just like my blue jeans. You Gen Z kids, though, you love holes in your blue jeans. I've seen it. I've seen it a million times. My dad used to say, I pay all that money for fabric. Why are there holes in them, you, Nick? That's what he would say to me. My dad's not in my life anymore. So we have this problem again. We have this guy right here, very similar to what we just did, but I have to factor it out. So let's factor it out. X minus 6, x plus 4, because two numbers that add up to negative 2 and multiply out to negative 24 are negative 6 and 4. And then we just have x minus 6 living downstairs. Okay, magic numbers. We have magic numbers living at positive 6, negative 4, and positive 6. Okay, 6 repeats up here and down here, so you're a whole. And negative 4 is all alone upstairs, so you're a 0. Now we're starting this off with domain. The domain is basically asking you, and we saw this in the last lesson, what are my values? What am I not allowed to plug in? Well, I'm not allowed to plug in 6. Okay, so we will say that the domain is everything but 6. So negative infinity to 6, union 6 to infinity. My holes are what x value gives me a factor upstairs and downstairs. Well, that's x equals 6. What are my zeros? Negative 4. X equals negative 4. What are my vertical asymptotes? There are none. Now, horizontal asymptotes. That's when things get a little bit wacky. Okay, and we saw this before as well. A horizontal asymptote is found basically with your end behavior. All right, now we find out the horizontal asymptote by doing the following. If your degree in the upstairs is the same as the degree on the downstairs, then your horizontal asymptote is going to have to do with leading coefficients. That doesn't happen here. If the numerator has a smaller degree than the denominator, then your horizontal asymptote is 0 no matter what. However, this guy has a degree higher in the numerator than the denominator, which means you don't have a horizontal asymptote. Now, y-intercept exists wherever x is equal to 0. So if x was equal to 0, you would go away, you would go away, and you would go away, leaving us with negative 24 over negative 6. That simplifies out to just positive 4. So my y-intercept is going to be positive 4. Okay? All right. Let's do it again. You're not completely factored, so let's factor you out. 4 is still up there. X plus 5 is still there. X minus 2 is still there. Two numbers that add up to negative or multiply out to negative 4 and our difference of squares is going to be x plus 2, x minus 2. Okay. The domain is, well, first off, let's find our magic numbers first. You don't have a magic number. You're negative 5, you're 2, you're negative 2, and you're 2. So we are not allowed to use negative 2, and we are not allowed to use regular 2 to plug in. So my domain is going to be from negative infinity to negative 2, union, from negative 2 to regular 2, union, and from 2 to infinity. My handwriting is on point today. Holes. Well, let's take a look at what we have. Negative 5 doesn't exist anywhere else, so you're a 0. 2 exists down here, so you're a hole, which means you're a hole. And negative 2 down here means you're a vertical asymptote. So my holes are going to exist at x equals 2, so my one hole is going to exist at x equals 2. My 0 is going to be x equals negative 5. My vertical asymptote is x equals negative 2. And now we're on to the horizontal part, the horizontal asymptote. Now, I know that down here is x squared. Up here is going to be 4 times x, and that's going to give me my leading coefficient. So we have a quadratic upstairs, 4 times x is 4x squared, and a quadratic downstairs, which means we do have a horizontal asymptote, and it's going to exist at the leading term over the leading term. So 4 over 1 gives me a horizontal asymptote at the equation y equals 4. My x-intercepts are what happens if I plug in 0. So if I were to go up here and plug in 0, right, I would get 4 times 0 plus 5, which is 5, times 0 minus 2, which is negative 2, over 0 squared, which is 0, minus 4. So these two 4's simplify out. So I have 5 times negative 2 over negative invisible 1. So 5 times negative 2 over negative invisible 1 is going to be negative 10 over negative 1. So my y-intercept is going to exist at positive 10. All right, now we're going to do some familiar stuff. We did this with polynomials. Now we're going to do it with rational functions. We are going to make a sine table for this graph that you see below. Let me zoom out just a little bit. All right. So what is very important are the zeros. So we're going to say you are a 0 at negative 5, and you are a 0 at positive 5. But you know what? I'm also going to focus on that vertical asymptote right there. So I'm going to label that as well. So little sine table, negative 5. We have, and I'll label that. I'll try to do that much more often because I like to do that. Z for 0, and then we got negative 2 VA for vertical asymptote. And then we've got ourselves a 0 at 5, regular 5, way down here. So the sine table is going to look like this. It's going to be negative, okay, because it's below the x-axis from everything up until negative 5. Then at negative 5, it becomes positive. Then at negative 2, you have the vertical asymptote explosion. It becomes negative again. And then it stays negative all the way up until 5, where it becomes positive. So that is my sine table. This is the way I do it. This is how I do it. If you think I'm a really good singer, then please like and subscribe. That's how I do it. Use that information above to make a sine table. I don't know if that's the same thing. Is it the same picture? I guess. I don't know. I guess we'll find out. But this is what I'm going to do. And this is how I'm going to find out. It can't be. There's no way it can be because this is a 4. Oh, you know what? It's talking about this guy up here, that G. Okay, so I see what I did there. I don't know why I organized it that way, but I got 4. Well, I have that information, so let's just remind myself what all that information is. Okay, I have 4x plus 5, x minus 2 over x plus 2, x minus 2, so I have magic numbers at -5, at regular 2, at -2, at regular 2. You were a 0, you are a whole, you are a whole, and you're a vertical asymptote. Okay, so that's some stuff that we know. So we have zeros living at -5, we have wholes living at 2, and we have vertical asymptotes living at -2. Another thing that's kind of important up there that I'm going to label is going to be my horizontal asymptote and my y-intercept. So my horizontal asymptote is y equals 4. Okay. Y equals 4. And my, what did I say? What was the other thing I needed? Was the other, y-intercept was 10, I believe it was. All right. Okay, so sign chart. Okay, so I care about all of this information. Okay, the wholes not so much, but I'm still going to put it in there. We have a 0 at -5. We have a vertical asymptote at -2. Okay, we have a horizontal asymptote at y equals 4, but I'm not going to write that out. We have a whole at 2, not that that's going to matter. VA, whole at 2. Y-intercept at 10, horizontal asymptote at 4. Okay, so that's a lot of the information that I have. So if you're wondering, how do I know what this is going to look like? Let's build ourselves a very basic sketch of the information that we have. Okay, a very, very, very basic sketch of the information that we have. The information that we have gives us a vertical asymptote at -2, a 0 at -5, okay, a whole somewhere over here that I don't know where it is, but more importantly, we have a horizontal asymptote at 4. And somewhere up here at 10, we have a y-intercept. Now, let's play the common sense game, shall we? If you're wondering, is it going to be something that looks like this? Or is it going to be something that looks like this? Well, there's only one way that this could work out. First off, my horizontal asymptote is at 4. It's going to level out at 4 no matter what, which means there's no way I can build a curve up here. Why? Because it's supposed to live down here. It's supposed to flatten out over here and come down here. Okay, then it's supposed to reappear way up here, go through 10, and flatten out at 4. This is the only way that this is going to make sense based off of the dots that we have. So what that means is u to the left of 5 are positive. Between -5 and -2 is below the x-axis, so it's negative. Between -2 and regular 2 over here at the whole, it's going to be positive. And from 2 on, it's going to maintain positive. And right here we have a hole somewhere. So that is how we're going to sketch the graph. We label everything we can, okay? We label everything we can, our zeros, our holes, our y-intercepts, especially our horizontal asymptote, and we go from there. Okay, put a bunch of dots and put a bunch of circles and a bunch of dots. All right, let's do this again. Make a sine graph. All right. So we have to label all of this stuff. Now, not only are we doing this, we are going to answer that inequality question. So we need to factor, we need to label, we need to draw as best as we can, find horizontal asymptotes, vertical asymptotes, all that stuff. Okay, so this becomes x plus 2 on the top, nothing special there, that's just a single factor. We could pull out a 3x, and that leaves us with x plus 2. All right, so what do we have? Magic numbers are going to happen at -2, -2, and 0. Okay, that gives me a whole at -2, a vertical asymptote at 0, and no zeros. And if you're like, how is that possible? Well, let's label out what we have so far and we'll try to make sense of it. We have zeros, okay, none. We have vertical asymptotes at x equals 0, crazy. We have a whole at x equals -2. Since my degree is higher in the denominator than it is in the numerator, it has a horizontal asymptote at 0. Remember, when that's the case, it flattens out at 0. So if it's going to have a vertical asymptote at 0, there's nowhere it's going to cross the y-intercept. So the y-intercept is also 0. So let's draw this out a little bit. Write out what we have. Okay, draw our picture. Okay, there's no zeros. Vertical asymptote at 0. Horizontal asymptote there. Our whole is at -2. Okay, so that's really the only thing that we're going to worry about. Our whole is at -2. Now, if you're wondering, I see what we need to do here. It's either going to look exactly like this. Okay, won't touch anything, right? Won't touch anything. It's going to look like we have zero help. Like none of this is helpful. None of this is helpful to get a picture. So how do I know what this is going to look like? Let's pick some arbitrary number that I know we're allowed to pick, that I know exists, like 1, and see what we get if we plug in 1. And what I'm going to do here is if I plug in 1, right, which lives right here or lives right here, if I plug in 1 and get a positive number, I know I get this picture. If I plug in 1 and get a negative number, I know I get this picture. So f of 1 is going to be 1 plus 2 over 3 times 1 squared plus 6 times 1. And it doesn't take a rocket scientist to figure out that this is going to be a plus sign. So our picture is going to look like this, okay? Whole, okay? So to answer the question, where is f of x greater than 0? All right, if I want to, I can build myself a sign graph, okay? Nothing happens at -2, but I'm going to put it there anyway. Whole is at -2, okay? Vertical asymptotes at 0. We have ourselves negative, negative, positive. Okay, so the only positive things that are going to matter are everything after 0. Now, if I cared about negatives, I would have to factor in the whole and say, I can't use -2, but that doesn't happen here. So we are going to say, where is f of x greater than or equal to 0? From 0 to infinity. And that's that. Okay, let's keep going, keep on trucking. Keep on trucking, as the truckers in the town say. God, help. All right, so what do we have? Similar looking stuff going on here. Let's factor stuff out. Okay, I can make you, let me see, two numbers that add up to -3, multiply out to -10. We got -5 and 2. I can pull out an x, and that leaves me with x plus 6. So our magic numbers are 5, -2, 0, -6. Okay, 0, 0, vertical asymptote, vertical asymptote. Okay, so let's label that out so far. I have zeros at, what did I say, just 5? Oh, 5 and -2. I have vertical asymptotes at x equals 0 and -6. No holes. Now, if I wanted to find the horizontal asymptote, Okay, since the degree on the top is the same as the degree on the bottom, we're going to focus on the y-intercepts. I'm sorry, the lead coefficients. I don't know why I said y-intercepts. My mind's getting ahead of it. So the leading coefficients is going to be 1 and 1. So that's going to give me 1 over 1. So a horizontal asymptote at y equals 1. And this guy is going to be, your y-intercept is going to happen when you plug in the zeros for x's. So when you do that, you all go away and you all go away, giving you an undefined thing. So there is no y-intercept. None. All right, so let's draw out what we can. Probably don't need to make a sign table for this. Just probably going to draw it out. Okay, zeros at -2. Zeros at 5. Boom. Boom. I will draw a sign table. Always do. Always should. Shame on me. Vertical asymptote is going to happen at the y-intercept and also -6 way over here. Okay. Then we have a horizontal asymptote at 1. And that's all I've got. That's all I've got. That's all I've got. Okay. So, first things first. Let's do the outsides. You are going to have to look like you because it's going to level out. Okay, it's going to level out at regular 1 and never crosses 0, so you have to go up here. Then what's going to happen is you are going to start back down here, go through that, and come back up, like so. So it starts up here, restarts down here, and then levels out. Okay? That's what you are going to look like. So, sign table. Sign table. No holes, by the way. Sign table gives me a -6. That is a vertical asymptote. It gives me -2. That is a 0. It gives me 0 vertical asymptote. And 5 is a 0. All right, all the way up until 6, positive. From -6. From -6 up until -2, negative. From -2 up until 0, positive. From 0 to 5, negative. And from 5 on, positive. I care about where this is negative. So this is going to be negative at 2 spots in between -6 and -2, and in between 0 and 5. Tricky, tricky, tricky. All right, now let's use a calculator to make a sign table. Just a sign table for this one. I'm not sure why a calculator is needed, but I guess we'll find out. Let's use our TI-84 Plus for this one. I think we'll get better results, so let's go and do that now. All right. Y equals, let's make sure we put our entire numerator in parentheses, x squared minus 5x minus 10. So I think I wanted you to do this on a calculator because I don't think you can factor that. In fact, I know you can now that I look at it. The bottom's fine. Make sure you put that in parentheses too, x minus tree. And then we'll graph. There you are, graph. Okay, so what we need to do is we need to find out our zeros. And we can see our vertical asymptote, but this is one of those ones where since the degree is higher in the numerator than it is in the denominator, we're going to have like infinities going on for our end behavior, and that's what you see right here. What I need to do, though, is I need to find out what my zeros are exactly. So this is what we're going to do. We're going to hit second calc, and we're going to do 0. Okay? You see the blinking thing show up. Go to the left of where it's a 0. Hit enter. Go to the right of where it's a 0. Hit enter. And we care about the 0 in between those guys. And by doing that, we get negative 1.531. Now remember, the rule for precalculus is 3 decimal places, so negative 1.5 3, 1. All right, negative 1.531. I am writing that down right now. All right. The other one, I'm going to do the same thing. X, second, trace, 0. Now let's move to the right of it until we see it reappear at the bottom. There you are. Make sure you're to the left of this 0. Hit enter. Go to the right. Make sure you're to the right of that 0. Hit enter again. And this 0 is 6.531. 6.531. All right? So, one thing that we'll deal with that in a minute. But let's go back and write out some information. All right, so the picture basically looked like this. Right? I didn't do a good job. Let me erase just a teensy bit of that. We have a vertical asymptote, okay, at 3. Now, I know that because there's a magic number, and that's 3 right there, and there's nothing to overthink it. Now, what I saw up here was nothing repeating here. I had to use my calculator, because you can't factor this. I had to use my calculator to find out the zeros. So we have a vertical asymptote at 3. Okay, VA is 3. No holes. This crossed... I know I'm not going to make it look like a good job. This had zeros at x equals negative 1.531. So negative 1.531 right there. And then also had zeros at, what was it, 6.531. So this is an awful looking picture that I drew. But again, let me just draw it out one more time, make it look a little bit better than I did, because that was just an abomination. Vertical asymptote at 3. Okay. A 0 at around 6.531, and a 0 at negative 1.531. Okay. This came up here and started like pointing downward that way, and then this came up and started pointing upward that way. Okay? So a sign table for this would have me putting dots at negative 1.531, 3, and 6.531. Okay? It's negative all the way up until negative 1.531, and then it goes positive from that number to 3, and then from 3 on that 6.5 number, it's negative, and then from the 6.5 number on, it's positive. Not the prettiest one ever, but we needed to use our calculator for it for sure, because otherwise you'd have to do the good old, whatchamacallit, the good old quadratic formula. Fun. The function f is given by f of x equals that quadratic x squared plus 2x minus 24 all over 4 minus x. Which of the following describes the function f? So they want x-intercepts, vertical asymptotes, holes, stuff like that. Let's factor out the top. Okay, that gives us, let me think, two numbers I multiply out to negative 24 add up to 2, so that would be negative 6. Nope, positive 6, negative 4. All over 4 minus x. Now this is where it gets weird. Notice the backwardiness. This is a negative 6 magic number. That is a 4 magic number. 4 minus what gives us 0? 4 minus 4 gives us 0. So that is still 4. So we have a 0 at negative 6, and we have a hole at 4. So a 0 at negative 6. Or they are calling it x-intercept, which is allowed. All of these have x. Okay, graph of x-intercept, so not creative at all. But a hole at 4 is just going to be b. I don't know why they decided to make all of them negative 6, but they decided to make all of them negative 6. All right, two more problems to go. Let's look at this last one differently. I'm going to kind of be lazy bones about this because I really don't want to graph that. It's a nightmare. You can graph it in your calculator. That'll be nice. But if you look at this, this is going to be x, 4x, x squared. That's a quartic, x to the fourth up here, and a regular x down here. It's not something that we're really used to in rational land. So what we're going to do is I'm going to factor as much as I can. So x still stays x. I could bring a 4 out of that second parentheses. So if I put it in front of that x, factoring 4 out would give me x minus 1. Factoring this guy out is I need two numbers that add up to -1 but multiply out to -6. So that's 4 minus 3. Did I say 4? X minus 3 and x plus 2. And put that over x plus 9 is its own quadratic. Now, let's find our magic numbers. 0, regular 1, regular 3, -2, and -9. What we need is we need numbers that result in negatives. So 0, 1, 3, -2 give us zeros, and -9 is undefined. So what I'm going to do is I'm going to eliminate any of these that have a 0, a 1, a 3, a -2, or a -9. Okay, so you have a 0 and a 3 in it, so you can't be the answer because you would be 0. And you have a 1 in it, so you can't be the answer because you have a 1, you would be 0. So I'm going to plug in -1 into this guy right here and see what I get. Okay, so let's plug in -1. So let's just do this factor at a time. Okay, plugging in -1. 4 times -1 is -4. -1 minus 1 is -2. -1 minus 3 is -4. And -1 plus 2 is 1. And that's going to be all over -1 plus 9, which is 8. Now, I do not care what the number is. I only care if it's negative. A negative times a negative times a negative times a positive is a negative. A negative divided by a positive is a negative. So -1 gets us a negative value. So far, so good. Now, let's try 2 and see what happens. Okay, 4 times 2 is 8. 2 minus 1 is 1. 2 minus 3 is -1. 2 plus 2 is 4. And 2 plus 9 is 11. Positive times a positive times a negative times a positive gives me a negative. You are 11, so you're a positive. And a negative divided by a positive is a negative. So A is the only possible solution for this because that's the only one that'll get us negatives. You do a lot of stuff like this in regular calculus where you kind of deal with negatives and you don't really care what the number is, you just care what the sign is. You're going to see that a lot in calculus. So what I did is very unique, but it will be seen. Now this is a different version of a sign chart. Now I'm going to make it look like my sign chart, because it's all about me. Looks like at -3 here we get a 0. Looks like at 0 here we get undefined, which implies either a whole or a vertical asymptote. I guess we'll find out. I don't know if it even matters. We'll see. At 2 here it's a 0. We are at positive, negative, negative, positive. So what this tells me is that first things first, if we're going to have two zeros at x minus 3 and 2, that means this must happen up here. If x minus 3 is a 0, that must mean that x plus 3 is a factor. And if regular 2 is a 0, that means -2, x minus 2, must also be a factor up there. Okay, now, that vertical asymptote or a whole, let's just pretend it's a whole. If that's the case, then it's going to look like this. So is this an option that we have? X plus 3, x minus 2 over x? Yup. So no, that's upside down and wrong. None of the above. Now the other possible option is if this was a vertical asymptote, but don't see that issue here. That's that. That's that. And that's that for this video. So as usual, like and subscribe. This is a pretty challenging lesson, very intense. But what you should do is go to my random videos, go to my site, type out 1.8 or AP Precalculus 1.8, and watch my random AP Precalculus videos about this lesson. I think it'll do you a lot of good. I know it should do me a lot of good. I should probably rewatch those myself because I felt like I was off my game in this video today. I started out strong with a great handwriting, but it kind of ended there with a blah. But anyway, thanks for watching. Please do like and subscribe. Please watch more. Don't give up on me. Thanks for watching. Love you. Bye.